So like applications, I think that might be what it is.
Okay.
Because, well, this is just another homework that goes along with it. And then I got this one. That's like a word one. I get the word ones. I can do those really good. But these, like that one was the hardest one. Like my mom had to help me with that one. That one took a really long time.
Okay, let me write that one up. This is doing some weird stuff. Let me just draw it all the way out. Okay, and the top one is A. This is E. And this is B. And this is C. And this is D. And they said, okay, so I want to take those two triangles and separate them, because I think that might be an easier way to look at it.
They had us do that. I think I did the work on a different piece of paper.
Okay.
But
well, okay, if you look at it, if you look at the pieces, right? When you're looking at one whole side, so if I were to mark that this side would be congruent to this side, and then this whole side would be congruent to that whole side. And then if I took these two pieces, then this piece is proportional to that piece. So I'm trying to make a proportion so that I am using the things that are congruent to one another, and I'm saying that they're equivalent to one another. So I'm doing the same thing that I did in that question before. I want to make sure that I'm marking the proper sides for each one. Okay, so if I'm looking at the proportions, let's see what they're actually trying to get us to find. They're trying to get us to find x plus 2. And then they said that this is 6. And then they said this whole side was 8. And they said that this piece was 5. Okay? So they gave me a whole piece and they gave me a short piece, right? So I'm going to put those two things in a proportion with one another. Okay? So I'm going to say that 5 over 8 is one of my proportions. Do you see those two different pieces? Okay? Now, if I want to figure out what this x is, I'm going to do the exact same thing. So where that 5 is, what number is the same as that 5 on the other side of the triangle? The 6. So I'm going to put the 6 there. And then the 8 would be what proportion or what side? How would I figure out the whole side for this side? Well,
wouldn't x be like?
I don't want you to look at x. I want you to look at the whole side. So how much is from A to B?
X plus 2.
X plus 2. That's the whole side. That represents some number. Okay? What's the piece from B to C?
6.
And how would you find the whole thing? What would you do to those two numbers? If you're asking for the whole, add them. So just add them together. So when you add them together, what do you get?
X plus 8.
Do you see that now? You see how if I were to make these different lines, let me make this a different color. This part from there to there is in red, right? So that's that whole side. And then the part in blue is just this piece. And so I need to find a red and a blue on the other side. Well, this is the blue piece, right? And then the red piece would be the whole thing. Now, in order to find the whole thing, all you got to do is add. Does that make sense? Okay, so let's try to solve for x then.
And then, like, I know the computer taught me a different way, but my teacher last year taught us to, like, cross multiply, and that's easier for me.
Okay.
I need that.
Mm-hmm. Do you see the different pieces? That's the most important thing. Because I can give you a question that looks like this. I don't know if the numbers are going to work out. I just want to make sure that you can write the proportions. Okay, so let me give you another question. Oh, Lord Jesus. Pardon me. I've actually given you an easier question if you just follow the same pattern. So we just want to see if we can look at the pieces, right? So what two pieces do I have both numbers for?
15 and 20.
Okay, so I'm going to make a proportion out of those two numbers. Okay, and I don't care which one you put on the top, which one you put on the bottom, so you choose. Okay, so you put 15 there, and then you put 20 there. Okay, now, what side does the 20 side belong to? The left or the right?
The right.
The right. So if I'm trying to make an equivalent fraction, what number goes there, the x or the 5?
This way.
You see how this 20 is here?
Mm-hmm.
Then the same side has to go, so the x goes there. They have to be across from one another. And then the 5 would go up there, right? And now we can just solve.
I used to be really good at doing this until last year. Everything was all calculator. Oh, anyway.
Right. You can just repeat it, it's fine.
Mm-hmm.
So do you get how I didn't have to find the whole side that time? I could just use the pieces that they gave me. So if they give you a whole side, then you have to use the whole side. If they give you a piece, then you have to use a piece. Does that make sense?
Mm-hmm. Because we made it, we just did that had to be 3 and it took us a longer time.
Right. You can't actually, let's do the question that way. Let's do the question that way. Because let me just erase some of this stuff. because I want to prove to you you're going to get the same answer either way. Okay? So you got the whole thing was 8. This part was 5, right? So we didn't know this part, but you can whenever you have a big piece and a small piece, you can subtract and you can find the part that's missing, right? So this was 3, like you said. Then this part was what? X plus 2.
And then like we finally figured out to add 6 to it. So then we kind of did like we were just doing.
Okay, well let's not do the whole piece now. Let's do it the same way we did this question. So set up the proportions for me. And look at it. When you have a question like this, you see this line? That line can act like your fraction. Do you see that? So if I extend that line out, I get that fraction, which is 3 over 5, right? And if I extend this line out, then I get x plus 2 over 6. So the question, when it's set up that way, actually looks like the question we need to solve. Do you see how those two things look exactly the same? And now let's solve it.
And it's like way easier.
That's what I'm here for. Good. Okay, what else you got?
So we can go over the test stuff that was.
Okay.
So we like went off of it before we figured out, because we can go back to it and know like all the stuff we got wrong. So I looked at it and accidentally went off too fast, so I only know a few were wrong. I knew that was wrong. I know this was wrong. This was wrong. Like the similar ones. Okay, so my mom wanted me to say that. So we had one that looked like this. The very first question we didn't write down because we thought it was easy. And then it had that. So we thought it was similar. And then there was one like this, but it wasn't the same. And then there was one like this, but they were connected and they both had like the there. So to me, I thought all of them were like similar.
Are you saying that this angle is congruent to that angle?
That's what it.
Okay. How many degrees do you have there?
90.
Okay, so put that 90 degrees symbol there. What is all you need in order to prove that two triangles are similar to one another?
2 angles. But it said it was wrong.
Okay, well, these two triangles are similar to one another, but they're actually identical to one another. Do you know how I know that?
Because it's mirrored. Or
Well,
flipped.
let's look at this. You know your postulates, like side, side, side,
Yeah, that's
angle, side, angle,
I think that's
angle,
what I
angle,
needed
side.
help with too, because those are hard for me to remember.
Okay. Well, where these letters are, and there's, I'm missing one.
Side, angle, side.
Side, angle, side, right. Did you guys do HL and LL for right triangles?
No.
Okay. Then I won't use that one. So we know that those two angles are the same because they're both 90, right? We know that that angle is congruent to that angle because they told us that, right? So if I'm gonna put some letters on this thing so we can look at the different pieces. And that's my crooked C. Sorry, my handwriting is really bad. All right. So you see this line BD?
Mm-hmm.
If I take this triangle and I put it in blue, and I take this triangle and I put it in green. Let me. What line do those two triangles share in common?
The line down the middle.
The line down the middle, BD. So I could actually put a line right there and say they're congruent. Now I have a postulate, and the postulate goes exactly in the order as you travel around the triangle. So the first thing that I come to is a what?
90 degree.
It's an angle. The next marking that I come to is a what?
Side.
And the last marking I come to is a what?
Angle.
So which one of these postulates proves that those two triangles are congruent to one another?
Angle, side, angle.
That's how you look at it. They're always in order as you go around the triangle, whether it's a side or an angle.
So you start here and then you go that.
Mm-hmm. Does that make sense?
Mm-hmm.
So those two triangles are actually congruent to one another, because that's an isosceles triangle. You'll actually learn that in the postulate.
So similar similar? They can't be congruent. They have to be.
Well, similar. Saying the two things are similar is just saying that they're proportional to one another. If two things are congruent to one another, then the proportion actually makes one, because the numbers are exactly the same. Like, for example, if I say that this is 3 and this is 4 and then this is 3, and I know that this side is congruent to that side, right? Then when I put those two numbers on top of one another, what do I get? 1. That means that those things are congruent to one another because proportion makes 1. Just like if I looked at BD in both triangles, it would be 4 over 4. That would give you 1 too, right? And that's when you know something is congruent. So congruent is kind of like a higher level thing. It's more specific, I guess I should say.
So why? So this one it wasn't. So we put yes, but it was wrong.
Because you have to have some postulate to prove that two things are similar.
And it only has one.
You only have one angle, so you would need to have another angle or an angle on a side. Or two things that said that they were parallel, like two parallel lines would actually prove it too.
And this one is like the same thing. I think this one was wrong. One of these two are.
Well, let's look at the proportion. So, which side is bigger, 10 or 18?
18.
18. So, if I do a proportion where I have 10 over 18. Oh, let me write this in another spot so I want around the room. So, I'm going to take the small side, which is 10, and I'm going to take the bigger side, which is 18, right? And then I'm going to do the exact same thing because I have that same angle inside, right? So I'm going to do the exact same thing with the other two numbers. So what number should go on the top of this fraction?
85. Oh. Wait, can you say what you just
Okay.
said?
Is that a side or an angle? That number right there.
Side.
Is that a side or an angle?
Side.
Okay. So
25.
25 over 45 because that's the small one, right? 25 over 45. Now, stick that in your calculator and see if you get the same decimal. So that means that they're not similar to one another.
So that one's right.
So that one's right.
And so that one, like, yeah. I'm pretty sure one of these were wrong. But now I know how to check.
Okay. You said no, right? All you need in two triangles to prove that they're similar is two angles.
So it's yes because in this.
Right. Because AA is the postulate for similar angles.
We got this one wrong, but I might be able to.
So do it now. That is really, really, really specific. Do you know what that line is called in geometry? It actually has a definition. And you're going to need to know it for your SOL when you eventually take it.
I think
It's okay.
the median.
That is the median line. How is the median line and the baseline, how are they related to one another?
They're parallel.
They're parallel, and there's something else that's really specific about them.
Congruent. No, because they're...
One is exactly twice as big as the other.
Is that what that... What is that? That's not... Does it tell you that, or is it just like, you know that because it's in the middle?
You know that because it's in the middle. So... Oh, this is z minus 3? That's what that's trying to say?
Mm-hmm.
Okay. Okay, listen to what I said to you. Okay, so I'm gonna write it up this way, and I'll draw the exact same way. And let's just use some regular old numbers. So what I'm saying to you is this small line, the big line is twice as big as the small. So if this number was 4, what would that number be?
8.
If this number was 10, what would that number be?
20.
So what do I have to do to the small line in order to make it equal to the big line?
Like double it?
I have to double it. So let's double it first.
26.
So that's 26. And that makes it equal to the big line. What's the equation for the big line?
Z minus 3.
So what would z be equal to?
23.
Mm-hmm. What do you do? What do you do to this number in order to move it?
Minus 29.
So 29. So when you have a median line, the small line is twice as big, or the big line is twice as big as the small. You just multiply the small line by 2 in order to find the answer.
I thought it, I don't know, maybe I was wrong, but I thought it said it was wrong. But I might be wrong.
That's a relationship, I don't know.
Okay. I think that one was right. It doesn't give you...
Determine whether the two triangles are similar below. Okay, well, take a ratio and see if the ratio is the same for both of them. What's the smallest number?
10.
Mm-hmm.
10 over
20. That's not going to work. This one's 1/2 and the other one's not 1/2.
So it's right?
So that should be right.
Yes.
Because there's... As long as those numbers are right, yeah. That's not going to work.
This one, we're not, when they overlap, we had trouble with those, but we did well.
Okay. Is that dot right there, G?
Probably, I forgot to write it.
Okay. What I would tell you to do is to separate the two triangles so you don't get confused, because they're giving you the whole piece. So if I were to draw a triangle ABC, and that's my right angle, right? What did it say AC was? What was the length of AC?
X minus 1.
And what is the length of AB?
3.
And then I'm going to write my right triangle on this side. And they're saying that this angle up here is congruent to that angle. And this is F, this is D, and this is G. Okay, what did they say the length of FD was?
8.
And what did they say the length of GD was?
X plus 2.
Now we got to make our proportion. So we want to put the same lines in the same proportion. So what two sides are proportional to one another, according to our picture? 3 and 8. Right, 3 and 8. So what do you want me to put? Want to put the 3 on the top or the bottom? Okay. Okay, now, what side is in the same triangle as 3? Because that's the number that goes there. Right. Oh, so you can see it now. What goes on the bottom?
X plus 2.
So as long as x is equal to 2.8, the triangles will be congruent to one another. Or similar to one another, I should say congruent. Now, if you were to do that question and the x's were to cancel out, so you would have no x's and then you would have something like, I don't know, 5 is equal to 8, because that's a possibility, then you know that the two triangles aren't similar to one another. That's what it would look like if that was wrong. Okay?
This one, because I got all the other word problems wrong with this one.
Two ships are leaving the same time. I don't see why that's wrong.
And I thought this one was wrong because that's what it said, like, we don't know.
So the answer is not 2.56? Because if I'm doing that, I have distance over time is equal to distance over time. The two ships are leaving the same marina at the same time. They are 3.2 miles apart after sailing 2.5 hours. If they continue at the same rate and the same direction, how far apart will they be in 2 hours? 2 hours later, that's the problem. That's the problem. Okay, so, our distance was 3.2, and then this was 2.5, right? We have to figure out what our new time is. How far would you be traveling if you traveled another 2 hours? How long would you be traveling altogether?
5.
5? No. Okay. If I leave the house originally at 7 o'clock, and then I look at the time and it's 9:30, what time will it be 2 hours from then? 2 hours from 11:30, right? So what do I have to do to that time? What do I have to do to the additional time? I'm giving you the answer in the word, the additional time. You add. So what would 2 hours further down the road be if you're already at 2.5? What would that be?
4.5.
4.5, right. So that's 4.5, and then this is going to be my new distance. Does that make sense? I guess the important part is 2 hours later. That's the point. Because you found out how far they would be after 2 hours, which made sense to me when I looked at it. But they're asking 2 hours later, so you have to travel an additional 2 hours. Does that make sense?
I have a hard time, understanding the 45, 45, 90, and the 30, 30, 90.
All right.
I'm 60, 90.
I'm gonna probably teach this to you in a different way, but it's good because we're gonna make a video of it. Okay. Here is my 45, 45, 90 triangle. So that's 45, and that's 90, and that's 45. If I look at that side, and if I look at that side, because the angle is the same, the sides have to be equal to one another. So I'm going to put an X there, and I'm going to put an X there. And then the side opposite the right triangle, the right angle, is always bigger. So this is going to be X root 2. And so we're going to do a bunch of questions dealing with each one of these sides. It's just a pattern, okay? So I'm going to do the pattern a couple of times so you can actually see it. So let's say this is my 45, 45, 90 triangle. And let's say this is 3. Well, that side is X, and this side is X. So these two sides have to be equal to one another. And the only thing that I have to do to find the third side is just take this 3 and put it where that X is. That's all I have to do. So that means that this is going to be equal to 3 root 2. So same triangle. If this is 5, then this would be 5, and then this would be 5 root 2. So you do this triangle for me. That's it. Okay. So that's the easy side to do. Hold on. Let's do a little bit of the harder one. So I'm going to redraw the triangle again. And this is x, and this is x, and this is x root 2. Now, I'm going to do a couple of the harder sides, and I want to see if you can see the pattern, okay? Because there is a pattern to this. So let's say that this side is 8. If that side is 8, you notice that it doesn't have a square root of 2 next to it, right? So in order to find this side, I take that 8 and I divide it by 2. What's 8 divided by 2?
4.
So this is going to be 4 root 2, and then that means that this side would be 4 root 2. Here's the next one. Let's say this is 6. If I want to find the other two sides, then this is 3 root 2, and this is 3 root 2. What if this is 4? What would the other two sides be if I'm following the same pattern? Right. So all I got to do is just take whatever that number is, divide it by 2, and make sure I put a root 2 next to it. Okay, let's see if you see this. How would I figure out the other two sides? I know the number looks funky. Okay. Remember that our equation for that side is this. So what would x be equal to? Say it.
5.
You're 5. Right. So what would this side be then?
5.
5. What would that side be? It's not too hard, right? Okay, now I'm going to go the other way. I'm trying to give you all the possibilities that you're probably going to see. Okay, so what if this is... When I went from this side to that side, then I got rid of the root 2, right? But if I'm going to go the opposite direction, I'm still going to get rid of the root 2. But instead of dividing by 2, guess what I have to do to that number?
Multiply
By
2.
So what would that number be?
14.
That's it. No root 2. Only one of the numbers has a root 2 in it. So what would this side be?
7 root 2.
So when you're going the other direction, you multiply these two numbers and you get rid of the root 2. That's all you do. It's not too hard to remember, right? Okay. So I can give you any 45, 45, 90 triangle. You can do it now, right? Okay. Give me the other two sides. Yeah, got it. Did you understand that before?
No.
No. But you got it now, right? Okay, let's do 30, 60, 90 triangle. So I'm going to draw the general one up again. I'm going to make this side 30. Maybe I should do it the other way, because that doesn't really look right, does it? So I'm going to make this side 30 and this side 90, and so this side would be 60. Now, in order to figure out the proportions, we always look toward the opposite side. So that side is going to be equal to x. This side is going to be equal to x root 3. And let me go back one, because I'll do it in a different color. And that side is always going to be equal to 2x. I'm going to do the two easier sides first, and then we'll deal with the one that looks funky later. Okay? So if this is my triangle, and this side is 30, and this 30 side is equal to 3. Then I'm just going to do what the triangle tells me to do. What side do I have? Which one of these three do I have? So in this picture, where is that? X, right? So what do I do to the x in order to find that side? What's that telling me to do?
Multiply by 2.
Multiply by 2, so multiply by 2. Right? What is the 60 side telling me to do with the x?
Root x root 3.
So tell me what number to write there. I'm just substituting I'm just substituting the 3 in for the x. That's all I'm doing.
3 root 3.
Okay? I'm going to change the orientation a little bit now. Because I can have my 30-degree angle there, right? Because I can just rotate it. So if this is 5, I'm going to do the easy one first. There's a hypotenuse, so I'm talking about that side. So what would that side be equal to? What does it say to do? What does it say to do?
2x.
So what would that number be there? Look at what I did. 10, right. That would be 10. What would my 60 side be, which is that one?
5. Yeah.
There's the 60 side, right? What's it telling me to do to the x? What did I do to it here?
Root.
All I did was take this number and plug it in where the x was, and then wrote the whole thing. That's all I'm doing.
5 root 3.
So that would be 5 root 3. Let's do another one. I put that on the wrong side, so let me move that. Oops. That's no good. Again, this is the 30 side. So that side is 14. You got it. And that side is 7 root 3. I know the number looks funky, but it's just a number. It'll give you a decimal. Okay? So they're always going to be in those proportions. Are you okay with the 30 side?
Mm-hmm.
Okay. Let's clear this. Okay, so I'm going to do the next hardest side. There's my 30 side, there's my 90 degrees, and I'm going to say that this one is 10. Where's my x side? Do you have? You don't have your picture, do you? I need you to write this in your notebook, okay? So you have this picture as a reference. Good. Good. Okay, so if I know what my 30-degree side is, I can figure out what all the other sides are, right? So I'm just going to start with my 30. Okay. Unless they give you the 60, but you still have to identify the two. So let me do another one. You have that picture drawn now, right?
Mm-hmm.
Good.
I already knew that one.
Mm-hmm. You okay with that now?
Mm-hmm.
Okay. Okay, I'm going to do one funky one. And I'll go through the math. It actually isn't that bad. And maybe I'll do a couple of these so you can actually see it. Okay, so what side did I give you?
The square, the root.
No, I didn't give you the root side that time.
X.
I gave you the x side, right? So look at what happens. When I give you the x side and it has a square root of 3 in it, then this is equal to 5 root 3 times root 3, because I have to substitute that into my formula, right? And I didn't write 5 root 3 twice. I just wrote the root 3 part twice. Okay? So what is the square root of 3 times the square root of 3? Do you know?
Square root of 9.
Which is?
3.
So what happens to the square root when you multiply those two things to one another?
It stays the same.
Okay, let's look at it. So I have the square root of 3 times the square root of 3, and that's equal to the square root of 9, like you said, which is equal to 3, right? Do I have a square root here? Do I have square roots there? Do I have a square root there? So what happens to the square root when you multiply by the same number under the square root? What happens to it? It was there.
It gets rid of this.
It gets rid of the square root. It goes away. That's what happens. So if I want to figure out what this side is, these two numbers became 3. So now I have 3 times 5. What's 3 times 5? So that's 15. Okay? So that means that when I'm doing the 60 side, that's just a regular old number. Right? So I had a root there and I get a regular number there. Now I have to deal with this side over here. So if this is my x side and this is my 2x side, the only number that I multiply by 2 is just the 5. So what is this number over here going to be?
10 square root 3.
Good. So just like in our 45, 45, 90 triangle, you end up getting 2 root 3s when that happens. You get 2 root 3s and just a regular old number. So let's do that again. right? I'm sorry, 8 root 3. Oh, sorry. I wrote 4 root 3 and you wrote 8. I can do that though. I can do that one. It's fine. So then this would be 16 root 3. That's right. What do I do to this 4 and that 3 in order to find that number? I don't even want you to do that. What do we know about the root 3s? The square roots. What happens to them?
It's just 8. Because they get rid of each other.
They get rid of each other. So all I do is just take, this is what I want you to do. All I do is just take this number times that number without the square root. That's all I have to do. So what's 3 times 8?
24.
24. That's all you have to do is just take those two numbers times one another and it gives you the other number. So let's do it again. You can ask her how it's going.
Feel better?
Hasn't been an hour.
Time flies when you're having fun, right?
Learning
All right.
geometry.
Okay. So do the other two for me. Yep. Okay, I'll let you go. I know you knew that already, right?
Mm-hmm.
You see the pattern now? Okay, one more, and then I'll let you go. So we just go the other direction. We still haven't gotten to the Sokotoa stuff, by the way. But
That's all right. Do it next time.
okay, this is 60. And I'm going to say this is 21. And I want to know the other two sides. When I had this side, what did I do to the 3?
It was rooted.
And what, in order to find that,
Multiplied.
I multiplied. So guess what I do with the 3 for that side? And then what do you add? Got it. Right. Perfect. You got it. You don't even need to do it. You got it. Good.
Thank you.
Yeah. Just for my own edification, when you walked in here, how did you feel about geometry 1 to 10, 10 being I had it? Where were you? I'm just curious with the stuff that you've done so far. Confidence level.
2.
Where are you now?
8.
Good. I'd rather have a 9 or a 10, but I'll take an 8. I'll take an 8. It's a drastic improvement. That's good. What do you want to do? Do you want to schedule one more before?
Yeah, I'll talk to her tonight, and then can I let you know tomorrow if we can do Saturday at 1 maybe?
Yeah.
If that would work, if we can figure it out.
That sounds fine.
Okay, I'll let you know tomorrow.
Okay.
Yeah. So she's input.
I think there's just some things that she needed shown.
It's
Just some
really
tweaking.
hard, I think, to learn online if you've
Never done it.
And at this age.
It's hard to do geometry with a teacher.
Yeah.
So, yeah, it's not easy. And some of the things, like when we were doing the proportion things, I just showed her how it already looks like a fraction, so just do it that way. And she was like, that makes it so much easier.
Yeah.
But if you don't know that, you don't see that, and nobody ever tells you that, it's harder.
Yeah, no, because they have, like, on Wednesdays, they have a 2-hour session they can go to. And I know she's went one Wednesday, the other one we didn't get to go, but she said, the teacher showed me I don't do it that way, I do it this way, and it was so much easier. So there's always,
There's a, like I said, I have a lot of tools, so I'll try to show it the way the kid learns. And most math teachers don't like when you do something that's different than them, but I just ask them, is it logical and does it make sense and is it the right answer? And if it is, then leave them alone.
Right, yeah.
This goes with 45, and in the other one.
Draw the picture for 45, 45, 90. That's the 30, 60, 90 one. Do you remember the picture for 45, 45, 90? 30, 60, 90, right?
X is down.
X is down there. X is right there.
Oh yeah, 2 X's and then
And then instead of having a square root of 3, you have a square root of what?
2.
What goes in front of that square root of 2?
X.
X. There you go. And like I said, both of them will be up on. I guess I can cut this off. I'll post it online.